In the frozen north of Russia, there is a rusted metal cap bolted to the ground. It's about 9 inches across, and underneath it is the deepest hole human beings have ever dug. It took 20 years. It went 12 kilometers straight down, and it made it 0.19% of the way to the center of the Earth. We have flung machines out of the solar system. We have photographed a black hole, but we have never come close to touching the inside of our own planet. And yet we know that down there, 4,000 miles beneath your feet, is a ball of solid iron as hot as the surface of the sun, slowly freezing. And that freezing is the only reason you are able to breathe. This is the story of Earth's heart and how we found it without ever going there. Start with that hole. It's called the Kola Super Deep Borehole, and Soviet scientists began drilling in 1970 with one simple goal: go as deep as physically possible. They expected to break through into a layer of basalt. They never found it. Instead, at around 12 kilometers down, they hit temperatures of 180 degrees Celsius, nearly double what they had predicted. And at that heat, rock stops behaving like rock. It turned plastic like warm wax and began slowly oozing back into the very hole they had drilled. In 1992, they gave up. The Earth had quietly sealed itself back up. For scale, they had not even made it halfway through the crust. If the Earth were an apple, they hadn't broken the skin. So if we can't dig down there, how do we know anything at all about the center? We listen. Every time a large earthquake strikes, it sends waves rippling all the way through the planet. Those waves speed up, slow down, bend and bounce depending on what they travel through. So seismologists around the world record them and work backwards, reconstructing the inside of the Earth from its echoes. It is like being locked in a pitch-black room and mapping it perfectly, just by shouting and listening to how the sound comes back. That is exactly how the inner core was discovered. In 1936, a Danish seismologist named Inge Lehmann was studying waves from an earthquake that had struck New Zealand 7 years earlier. She noticed waves arriving in places where, according to every model of the time, no waves should have been, as if something deep inside the planet had bent them. Her conclusion: there is a solid ball at the center of the Earth, sitting inside the liquid core. She published it in a paper with one of the shortest titles in scientific history. It was called simply P prime. The boundary she found still carries her name today. So what is it exactly? The inner core is a solid ball of iron about 2/3 the size of the moon. Its temperature is roughly 6,000 degrees Celsius, about as hot as the surface of the sun, which raises an obvious question: why isn't it liquid? Because down there, pressure wins. The entire weight of the planet bears down on that center with roughly 2 million times the pressure you feel at the surface. The iron is squeezed so violently that its atoms physically cannot break free and flow. It isn't solid because it's cold, it's solid because it's crushed. And here is the part that changes how you picture it. The inner core is growing. Every year, molten iron from the layer above freezes onto its surface, and the solid center expands by about 1 millimeter. The heart of the Earth is slowly turning to stone. That sounds like a footnote. It is actually the most important process on this planet for you personally. When that liquid iron crystallizes, it releases heat and lighter material that rise and stir the molten outer core, churning it like a pot on a stove. Churning liquid metal generates enormous electric currents, and those currents generate Earth's magnetic field. That field stretches far out into space and wraps the planet in a shield. And it is holding back something genuinely violent: the solar wind, a constant stream of charged particles from the sun that would otherwise strip our atmosphere away, molecule by molecule, and blow our oceans into space. We know that isn't just theory because we can see where it already happened. 4 billion years ago, Mars had a magnetic field too. Then its core cooled, the churning slowed, the shield switched off, and the solar wind scoured Mars down into the dry, thin-air desert we see today. Mars isn't a different kind of world. Mars is a preview. And it is still moving. By tracking earthquakes that repeat in the same spot across decades, scientists found that the inner core does not spin in lockstep with the rest of the planet. It sped up, then slowed, and is now drifting backwards relative to the ground beneath your feet. The heart of the Earth is changing speed, and we are still arguing about why. So the next time you take a breath, think about what makes it possible. Thousands of miles below you, a ball of iron as hot as the sun is quietly freezing in the dark. And that freezing is the only thing standing between us and the fate of Mars. We have never seen it. We probably never will, and it is keeping us alive anyway. I'm the onlooker. Keep looking closer.